Hey guys, my name is Stefan Thomas. I'm CTO at Ripple, and today I want to talk a little bit about how XRP works, what it is, and what's special about it compared to other digital assets out there. So, first of all, the problem that XRP is trying to solve is today the way payments work internationally is that companies will actually pre-fund all over the world and kind of hold funds all over the world to the tune of $27 trillion in total. And that's money that's not being used, that's not being reinvested, that's not being loaned out, that's money just sitting there in case you want to make a payment into a certain country. And we think that that problem can be addressed with digital assets. Digital assets are like gold that you can move anywhere in the world instantly, and so they provided an alternative to pre-funding liquidity all over the world. As a company, we build solutions for banks, and so we go out to banks and we help them reduce their costs with cross-border payments. What's that? Okay, sorry. We help them reduce their costs with cross-border payments, and part of that story is we think that we can reduce the cost even further if we introduce digital assets, because we can reduce the cost of liquidity on top of some of the other efficiency improvements that we can do with the technology. Okay, now when you reduce the cost in a system, what that can do is it can vastly increase the volume that's going through that system. And so I think a lot of people today are thinking about, well, given the current payment volume, how much cost reduction can we achieve? And that's actually missing the bigger point, which is aside from the cost reduction, there is a huge amount of potential new business that can be created if you reduce the cost of payments worldwide. And that's what we call the Internet of Value. When the volume really explodes, that's what we call the Internet of Value, and that's our mission as a company. So as we're designing that digital asset, there's certain properties that we want. If you want to use an asset for settlement, especially in a bank context, there's a couple of different criteria by which you'd want to evaluate those assets and that you want to design those assets for. The first one, of course, is speed. We already said that the whole problem with the system today is that payments take too long, and that causes a lot of costs in terms of having to pre-fund. And so obviously our asset has to be fast. You have to be able to move it anywhere in the world instantly. It also has to be consistent. So what that means is you want that speed to be the same all the time. You don't want the asset to be sometimes slow, sometimes fast, because then you can't rely on it, and you have to price the risk of it being slow into your rate anyway, right? So you want it to be consistently fast. Next, you want it to be cheap to move around. So you don't want very high transaction fees. So the lower your transaction fees, the better. Next, you want it to be scalable. So you don't want an asset where you can make few transactions, but as soon as it gets popular, it kind of breaks down. And then finally, some of us care about the environment, and so you might want an asset that doesn't waste a lot of power, electricity, etc. And that's just something that we didn't really think about a lot in the early days of Bitcoin, but as Bitcoin gets bigger and bigger, this is becoming more and more of a concern for a lot of people. So just as two examples, I'm going to compare Bitcoin and Ripple just as the most prominent sort of proof of work based system, and as well as the most prominent Ripple consensus based system. Now, first big difference between proof of work and Ripple consensus is that proof of work requires multiple confirmations. And that's because in a proof of work system, there can always be more miners out there that you don't know about. And they might have more blocks, and they might have a longer chain than you know about. And so you can never trust that you're done. You can never trust that a transaction is final unless you wait a little bit to make sure there aren't any blocks that are still kind of being generated somewhere else that you just haven't heard about yet. So the longer you wait, the more confident you get. By contrast with Ripple consensus, the identity of the validators is decided up front. So before you even try to validate a ledger, you know which validators' opinions you care about. And so as a result, we can get finality even if we just have the first validated ledger. If it's validated, it can't be reversed. So you get finality much quicker. So if you look at it from a perspective of the frequency with which you can confirm transactions, you can see that with Bitcoin, I can only get within 1 hour, a couple of blocks, a couple of chances to get my transaction confirmed. And if I'm waiting for 6 confirmations, there's a pretty good chance I'll be waiting for more than an hour. By contrast, Ripple processes transactions within a few seconds. And the other thing that's interesting is if we zoom into the first part of this chart, the frequency in Ripple is incredibly consistent, right? So we close ledgers around every 4 seconds. as opposed to the random nature of proof of work, where blocks are generated at random intervals, and so that interval could be very short or it could be very long. And so if you're processing payments, it's a nice benefit to be able to process so consistently. And finally, because we only need one confirmation, that kind of exacerbates the speed difference because we don't have to wait for lots of confirmations. So in these categories, Ripple really has a very strong benefit. Talking about the cost is clearly in favor of Ripple. We charge, or the network charges only about 0.03 of a cent per transaction, whereas in Bitcoin, the average transaction fee is nearly $2 right now. Now, some people might say, like, okay, well, your transaction fees are low, but that's just because you don't have a lot of transaction. And so I pulled up this chart, which is basically showing like the transaction volumes in different cryptocurrencies, or like in different blockchains. And so Ripple actually has more transactions, about 3 times more transactions than Bitcoin right now, which is owing to some of the more advanced functionality that exists in the network, orders and so on. And so people are placing orders, canceling orders, so it's actually causing much greater transaction volume than you even see in Bitcoin or Ethereum. Obviously, we think that Ripple has a huge amount of room to grow. So you saw some of the spikes in that chart. So actually, we're not running at capacity, or the network's not running at capacity. It can grow quite a bit more. Whereas with Bitcoin, I think it's pretty much at capacity, right? There's actually a transaction backlog of transactions that can't get processed. And finally, of course, this is the easy one, because proof of work is heavily dependent on this sort of work that costs a lot of electricity. So obviously, that's costing a lot of that. Whereas with Ripple Consensus, you basically cut that part out and you just go straight to validation, which is relatively efficient. Now, all of these things are kind of the end benefits that you see as a user, right? As a user, I can move money around very cheaply. I can move money around very quickly. Those are the things that I care about when I want to use a digital asset. But of course, we also want to talk about how we can guarantee these benefits in the long run. How can we guarantee those benefits in the future? And so that depends a lot on governance. So the way that Ripple is governed, or the way that XRP is governed, is it's an open source project. It's up on GitHub. The way that new features get added is people make pull requests on the GitHub project. And if the maintainers decide that they want to include that particular pull request, it gets included and deployed. And then miners vote on new features, which are called amendments, by basically their position in the topology. And then once they've voted with a supermajority, then the feature actually goes live. Now, this is pretty similar to how it works in Bitcoin, except in Bitcoin, the miners are not chosen by the users, but rather they're basically self-appointed. Like they can become miners, they can get voting power just by being efficient at mining. And that's a big difference. In Ripple, it's kind of more like a democratic process where users choose which miners that they want to listen to. And so miners that are listened to a lot, they tend to get more influence in the network. The other thing that's kind of different is that in Bitcoin, a lot of the voting power is very concentrated. So most of it is in China today. Whereas with Ripple, the validators are globally distributed. So there's validators in a lot of different countries all around the world. And we're proud to have validators in like most time zones. And then next is kind of like whenever you're talking about a distributed system, so like any textbook that you pick up, the first thing they'll tell you is the distributed system is only reliable if the individual nodes in the distributed system are reliable. Because if too many nodes fail at once, the whole system breaks down. And I think that's a lesson that as a community we haven't really internalized yet, because there haven't been very many large-scale failures. But it's definitely a risk, and it's something that other distributed systems have experienced over the years. And so one thing we should think about is actually the quality of the miners as well, the quality of the validators. So in the case of Bitcoin, a typical Bitcoin mining operation is very much built for efficiency. It's very much built for how cheaply can I hash. So you have these racks of computers, very bare bones. You have the absolute bare bones infrastructure. This is from a mining farm in China. And compared to that, like with Ripple, the way the validators are chosen is by the users. And so users care about the quality of the validator, the security, and so on. And so Ripple validators are quite different. This is a picture from one of the Ripple validators in Tokyo, which is an absolute state-of-the-art data center. They really know what they're doing. They have top-notch security, these vein scanners to check your vein patterns when you enter. So I feel a lot more confident that you can't compromise a large number of Ripple validators as easily as you could compromise a number of Bitcoin mining pools. And then also the particular server room that the Ripple validator is located in hasn't been down ever since this was built in 2001. So they also provide very good uptime which also helps the network uptime and network availability. So if we take all this together, XRP is just the best asset for settlement, for payments, especially in an enterprise context. So if you want to actually move large amounts of money around using a decentralized network, you can't do better than XRP today. So thanks for paying attention, and this is my XRP explainer.